Okay, so today we're going to talk about what happens when we graph proportional relationships. But before we do that, let's take a moment and review some things about graphing. If you remember, when we graph on what is called a coordinate plane. And if you remember, a coordinate plane looks like this. No, I'm kidding. That's a regular plane. A coordinate plane is made up of two axes, like so. The horizontal axis is known as the x-axis, and the vertical axis is known as the y-axis. Now this is going to get a little bit tight, so let's do that. The x and y axis break things up into four quadrants. This is known as Quadrant 1. And we use the Roman numerals to identify what quadrant it is. This is known as Quadrant 2, or Quadrant II. This is Quadrant 3. And finally, we have Quadrant 4. Now, the two axes meet at a single point. Anyone know what that point's called? Yep, that's the 0, 0 point, or we call it the origin. Now, every point, or what we call ordered pair, let's write that down. Every ordered pair has the form x, y. That means we go over on the x. We either go left or right on the x, and then we go up or down on the y. Now, when you think about Quadrant 1, all the points in Quadrant 1 have something in common. Do you know what that is? Yeah. The x is positive and the y is positive. What about Quadrant 2? What do they have in common? Yeah, the x is negative and the y is positive. It's winking at you. Quadrant 3 we call the Sleeping Quadrant, because it looks like the points are fast asleep. It's a negative, negative. And finally, Quadrant 4 is the positive, negative quadrant. Good. So if I was to do this, if I was to draw a quadrant out, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. I'm just roughly sketching a quadrant here. If I was to say to you, can you label the following points? 3, 2, negative 1, 4, and 0, negative 2. Can you label those? Pause the video and try to label those points. Alright, let's see how you did. 3, 2, you would have gone over 3 and up 2. There's the point 3, 2. Negative 1, 4. You would have gone back negative 1 and up 4. 0, negative 2 says don't go anywhere, just go down 2. So there is 0, negative 2. Hopefully that's what your graph looked like. When we're looking at identifying proportional or non-proportional relationships, we take a look at, for example, we take a look at our charts. So for example, if I gave you time in minutes versus distance in feet. And if I said I can go 0 feet in 0 minutes, 6 feet in 1 minute, in 2 minutes I can go 12 feet. In 3 minutes I could go 18 feet, and in 4 minutes I could go 24 feet. Now, if I draw the graph of this, and the way I'm going to draw the graph, and I'm going to keep it pretty simple here, I'm going to do minutes on the x-axis and feet on the y-axis. And here on the x-axis, I can go simple, 1, 2, 3, 4, and 5. On the y-axis, I don't want to go up by ones, because that would be a really big one. So I'm going to go 6, 12, 18, 24. As long as I go up by a constant rate, I can do that. If I went up like 2, 7, 15, 35, I can't do that. It has to be the same interval going up. If I graph each of these points, 0, 0, 1, 6, 2, 12, 3, 18, 4, 24, notice what it does. It creates a straight line that goes through the origin. That means this is proportional. If it creates a straight line going through the origin, then it is proportional. Now take a look at this chart. I have the number of games, and I have the cost of the game. So one game costs $3, and we're going to do this in dollars. And 2 games cost $5, and 3 games cost $7, and 4 games cost $9. So here again, I'm going to draw my graph, and I'm going to do games here. I'm going to do cost here. And we're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm going to go 2, 4, 6, 8, 10. So one game costs $3. 2 games costs $5. Now you notice I'm going to have to kind of alternate a little bit here. 3 games cost $7, and 4 games cost $9. Now, while this does do a straight line, the problem I find is that it does not go through the origin. So if it does not go through the origin, or it's not a straight line, then it is non-proportional. So as we find, in order for it to be proportional, we're going to have to go through the origin and create a straight line. Okay, so I want you to try this one. And I want you to tell me if it's proportional or not proportional. The number of seconds to the number of rotations. 0, 0. 5 seconds is 2 rotations. 10 seconds is 5 rotations. 15 seconds is 10 rotations. I want you to make the graph, and then tomorrow when you walk into class, you need to tell me if it was proportional or non-proportional. See you then.